And welcome to Frame for Success, How to Avoid Callbacks. And this presentation's been reorganized in a way that we're not going to just look at the mistakes. While that is entertaining and educational to see issues that other people have had, it's best to be able to group these and organize them into the key issues that cause them. So these 5 keys that you can take with you after today's session should help you avoid the mistakes that we're going to review. So first, and most importantly, wood has a strength direction. 2, we need to realize that wood does move and to account for that in our design and framing. 3, consistency is very important. And 4, moisture intrusion needs to be minimized. 5, load path continuity is key. So beginning with wood as a structural material, and in this photograph, you'll notice a group of gentlemen standing on a plywood panel, and we see the strength provided. And as structural engineers, again, this is something near and dear to our hearts, that the strength and the bones of the material come into play from the products that we design for the structure, whether that's wood, concrete, or steel. And so with wood specifically, you can think of a piece of wood like a bundle of straws, and you press that bundle of straws together or pull it apart, and it's very strong. And we take this same bundle of straws and provide a load perpendicular to it as shown on the right hand side, and we see that it's much easier crushed. So you want to avoid that tension perpendicular to grain loading with the products. And even as they're manufactured, they take this into account to maximize the strength and minimize the weakness. So looking at the products, if we start with the plywood panel, you see that plywood is created from a series of plies of wood oriented in such a way to maximize the strength. We have the veneer at the top and the back with the strong direction of the wood and the long direction of the panel. So you can remember that long equals strong. And then the veneer next to the front and the back are oriented in the opposite direction. And so having that cross orientation is going to maximize and increase the stiffness of the panel. The panels are glued together with moisture resistant adhesive. So having the cross orientation of the veneers as well as that glue is going to also maintain and maximize the dimensional stability, because what happens when wood gets wet? It wants to expand, and so the cross orientation is going to help that resist that movement. And again, the moisture resistant glue is going to minimize how much moisture can even affect the panels. Now with OSB, it's created in the same process. So if you look closely at an OSB panel, oriented strand board, you'll notice that those strands are primarily oriented at the face and the back with the strong direction of the wood and the long direction of the panel. So again, long equals strong. And then the strands in between are in the opposite direction where they're cross-oriented, again, to maximize the stiffness, and using the same glue provide that dimensional stability and performance of minimizing that effect of the water. The design criteria that's used for our panels is shown here. So on any of the grade stamps that you'll see on the product, it's based on this design criteria. So for a roof span, that would be a deflection limitation of L over 240, 30 PSF live load, 10 PSF dead load. For the floor, L over 360 for the deflection, and then 100 PSF for your live and 10 for the dead. So question for you, what's typically the live load that you're designing for on your floors? Sometimes we have 100, but often we're looking at more like 40 PSF. So this is good information to have to recognize that the span rating is based on 100 PSF. Which brings us to one of our first framing errors that we see, and that's the sheathing installed incorrectly. So as I mentioned before, long equals strong. We want to have that long direction across our supports and across at least 3 supports to create a continuous span, as we see on the bottom right-hand side. The bottom left is simply supported, and if you think back to your moments, you will recall that our continuous span has a lower moment than a simple span. So if the design criteria is based on the continuous span, which it is, it would be exceeding it in a simply supported application.